welcome to today's session. It's going to be a wonderful session today, right? Um, like we said, the purpose of this is just to ensure we are able to share our knowledge with you. Now, if you know you haven't registered, I will advise you register so that you can be able to be aware of our sessions that we have planned for you for this quarter. So we're having an interesting speaker for today. He's none other than Tayo Fatoki. So I'll be bringing him up stage now so that we can have a discussion with him. Hello, Tayo. How are you doing today?
Hi, Promise. I'm very well, thank you. How about you?
I'm doing great. How's your day going?
Good, good. It's been a busy one.
So, what do you have in store for us today?
Yeah, so today I will be discussing implementing security and validate code base for compliance, something around the areas of DevSecOps.
Nice, nice. This actually sounds very, very interesting. Well,
Thank
with
you.
your permission, I would just say you can go ahead and do it, and I'll just guess as. So over to you,
All
Tayo.
right, sure.
All right,
Thanks, Promise.
you're welcome.
Okay, try and share my screen, and we are live. So thanks very much for coming on this session, everybody. Today we'll be discussing how to implement security and validate our code base for compliance. This is a continuation of our previous modules on AZ-400. And here we go. So my name is Tayo Fatoki. I'm a solutions architect and a spheres of tech. Um, and I'm excited to be on the show today. So this module will be discussing introduction to secure DevOps, implementation of open source softwares, software comparison and analysis, static analyzers, OWASP and dynamic analyzers, as well as security monitoring and governance. I'm going to try to go as smooth as possible. So feel free to ask your questions, which we'll take before the end of the sessions. Right. And of course, we're going to have a lab session, which, if time permits, we might be able to do. And if otherwise, we'll be happy to discuss it some other day. So, uh, security is a key component of any IT infrastructure. It's a way of ensuring that your architecture that you have designed for every other resource to sit upon are securely in place. It's also a means of ensuring that every party or stakeholder using any form of that infrastructure is constantly keeping in best security practices. And of course, also helping you to continuously monitor your environment to prevent attacks that could be anticipated by several tools. We'll go into details with that. And I'm just going to give you a quick example. There's a type of attack we call SQL injection, which is a simple story of, let's say, a database, and users just access that app and the database, and the developer constantly communicates with the cloud infrastructure, ensuring that every other resource that we have there are securely in place. Now, you have your users constantly browsing and everything works well, but there are instances where certain people who are really to orchestrate a malicious attack of some sort to the environment. Part of that kind of malicious attack is what we call the SQL injection attack. And SQL means structured query language, and injection is a way of exploiting your database tables in checking if they can access very, very valuable information. And somewhere you have an attacker from anywhere in the world looking around, trying to exploit your app and getting records of your SQL database. you have on the screen here, put in a username and some random hyphen text, which will query the database and return by allowing the attacker to log in if certain processes are not put in place to prevent SQL. Just a simple might be able to get access to your application and database and still vulnerable information. Now, you don't want this kind of situation to happen to your application, neither do you want it to ever happen to your infrastructure. And that's the reason why we're talking about DevSecOps today. And certain tools that can help you to prevent this from happening includes audit logs, threat anomaly detection, vulnerability assessment and penetration tests, and a whole lot of other things that we'll discuss today. Now, what exactly is DevOps? DevOps is a process of ensuring that developers and operations team collaboratively work together for a common goal and ensuring that there is no wall of barrier between the two of them. Now, you need to secure that practice because DevOps is a practice and you need to secure that practice. And DevSecOps is a way of ensuring that that practice, every single step of that practice is securely carried out according to best practice. The goal is to enable the development team to work fast without introducing any unwanted vulnerabilities. And finally, the security strategy includes access controls, environmental hardening, perimeter protection, IAM controls, and a whole lot more. Now, when you look at the features that we have in the DevSecOps space, you'd see that this DevSecOps starts from when you have a security team and you have the dev, and both of them unite to form the DevSecOps team. And this is exactly what we are trying to achieve in this space. Now, DevSecOps is more or less a secured way of practicing DevOps. Is a way of ensuring that every step of your DevOps practice is adhering to best security practices. This starts from either when you're compiling your code on your local terminal using certain IDs that have security plugins to when you push your code to the repository and there are commit checks to ensure that your codes do not have secrets exposed to the public, to where you have your secured CI/CD pipeline to ensure that when you are building your applications, the images or the code base or the dependencies that you are using to build that pipeline is secured and you're not using outdated dependencies. So even when you want to deploy the application to an environment, and in that environment, you ensure that in your deployment space, what you're deploying is a secured artifact or a bundle or a package. And as well as continuous monitoring after building, you need to constantly monitor your application. So putting security at the front burner of each phase of our CI/CD pipeline is all the primary summary of DevSecOps. It goes above beyond that, but the primary summary of doing a DevSecOps is to ensure that your entire app infrastructure and app is completely secure. Now, how do you explore a secure DevOps pipeline? You have a team, and in this case, uh, this team could be your team of maybe developers, and your developers have a uh, package manager that they are using to build their applications on their local machine. And after using this package manager, before you start to use that package manager, you can plug in certain security methods into the ID to ensure that what you're building on your package manager or whatever ID they're using is going to ensure that you do not use compromised code base or compromised dependencies. And this also goes into your version control tool, which can either be something like any kind of Git repository that you know of. We've got Azure repos and Azure that we use, and we've got a whole lot of others in different environments, ensuring that your code that is being pushed has a pre-commit check that ensures that you do not commit critical and sensitive information into your code base. And there are different ways that we can achieve by doing this. The different ways you can achieve this. We have certain ways you can use a ignore file, or you have certain security tools that can help you to scan this while you're about to commit your code, which we'll still mention later. And then you also have the build and CI/CD agent that can help you to look at what you've committed and what's about to be built to ensure that you do not have any vulnerability there. And this can be integrated with a source scanner of some sort that helps you to check if your code contains what is not permitted to get out to the internet. And then you also release with testing, and then to a dynamic scanner, and then deployment, and finally monitoring. So this is like the journey of our secure DevOps pipeline. Now, just to give you some more context into it, on my screen here, you have on the left the IDE, or where you do your commit or your pull request. You push your code into the repo, and just before that code gets into the repo, there's a static code analysis tool that helps you to check either on your IDE, or wherever you're committing your code to help you check and validate that you're not committing sensitive information into this environment. And then this also happens when the checks is complete. It allows your code to proceed to trigger the CI platform, which is a continuous integration platform that checks for vulnerabilities, library dependencies, runs some tests, checks for static code rules and warnings. And if all that goes successful, it moves into the build stage, or the development stage, where you have the penetration test issues being discovered, SSL issues being discovered. You can use passive scanners or SSL scanners or infrastructure scanners. And this can also help you on the side run some form of load and performance testing and automated regression testing within your infrastructure as a code. And then finally, you can have a test, either can be a performance test or some form of penetration test, to ensure that this code is of high quality before it's released to the environment. You don't want to build an application where your users' primary data, e.g., their name, phone numbers, or whatever personal information that they may have that they are storing on your database. You don't want to build an application that will give off people's personal information to the internet. So now, based on the understanding that we've established previously, if you need to remediate, we just want to give you some context into it. Let's say you do not adhere to best security practices from your build stage. Now you have a developer that can have an IDE, and that IDE might have a pre-commit check plugin of some sort sitting on their IDE integrated with your SaaS service, or you can have Microsoft Azure, some kind of pre-commit checks also that helps you to check your Azure code that you're committing to your Azure repos. If you do not tackle that issue at that stage, if you're tackling it at that stage, it costs you about $80 to solve a defect. Now, if you move into the build stage and you do not solve it on the coding level, when it gets to the CI platform, it's costing you three times that amount, which is about $240. And when you move into the QA and the security stage, it gets to nearly $1,000 just to solve a simple bug that could have been solved by as little as $80. And then finally, in production, when you have a defect, and this cost that you're looking at here is very, very moderate. If you look at it from the grand scheme of things, if a customer's information or your user information or your staff information is exposed to the internet, the dire cost of fixing that, um, reputational damage to your company, or the cost of remediating a ransomware or some form of hack that's happened to your company, is way more than the $7,600. But if we're looking at just fixing the code alone, this is how much it takes to fix a single defect. Now, you can reduce this cost by moving left. Now, there's a term that we call the shift left, which means empowering your developers more, moving some of the things that should be done after development to the development stage. It is not as if you're creating more work for the developers. It is you enlightening your development team and your DevOps team to ensure that you constantly produce high quality secure codes using automated tools and processes to identify the problems and resolve it before it gets into the production environment. Now, with this, I need to also explain what the threat modeling is about. If you need to solve this, now, if you understand that you need to do this and you're ready to do this in your organization, you need to understand threat modeling, which means how do you solve this? How do you implement this in your environment? The first thing is to define your security requirements based on the kind of app that you're building. Now, after after developing the security requirements, you create an architecture diagram. It's very, very critical for you to have an architectural diagram. There's a saying that what you cannot monitor, you cannot have full visibility and control, but you want to have full visibility into your application. So a clear diagram of the architectural process of how your code goes from build stage to other stage needs to be done. And then after creating your application diagram, you identify the threats, potential threats that can happen within that application diagram, and then you come up with a plan that mitigates that threat. Now, once you have this that mitigates the threat, it allows you to validate that the threat has been fixed. After you plan for it, you fix the issues, and then you go back to validate that the mitigation has been solved, and that resolves the problem permanently. And if you look at this diagram that I'm just sharing with you, this is the whole process. First of all, like I said, you define the targets of the threat modeling, and then you go into the architecture diagram, and then you identify every potential bottleneck, and you try to mitigate those bottlenecks even before the applications are built, and then you finally validate that this is resolved. Now, I'm going to go into a demo much later, but I just need to quickly explain something to you. Um, there's a common concept about what people call open source. What is an open source software? A lot of people use open source applications globally. I use them, everybody uses them. I'm a big fan of open source. It's just the way technology continues to innovate itself without anyone spending a whole lot of money on it. Now, open source software has been very helpful, but it's got its pitfalls. It has enabled us to do a whole lot of things. It has integrated with their existing platforms. It has allowed us to release more and better code. And that also have a group of bigger organizations and corporate organizations that have come into it and contribute to the open source community. And part of them, and a lot more, I already listed here on the screen. And you can also go to open source, the Wikipedia page that you have there, to let you know more about different open source contributors globally. Now, what are the challenges of the open source kind of softwares? Number one, it would impact maintainability and reliability and performance of the overall solution because you don't have full control over it. It's something that is built from a different community, different people contributing different kind of code to ensure that an application starts to perform better. It's great, but you don't know who's contributing different codes. You don't know if someone is contributing a malicious code at some point, and it might skip, it might not be intentional, it might just be something that happened, unintentionally, but you don't have full control over it. And then there is no regular maintenance except you guys form a body that will be solely responsible for maintaining that code, which means that body would have to start accepting the code when it's being committed. And then you also have some issues where you can have serious vulnerabilities. Maybe somebody using a dependency that has been found to have expired. For example, recently we had an attack on log4j. Sometimes last year, end of last year, there was a log4j vulnerability that was found, and it compromised nearly all Java applications that were running on a particular version. Now, these are some of the issues that happened on the open source environment. And now, according to the open source, and it's not intentional, it's just because of how open source is built. An open source application is built not to discriminate against any person or group, not to discriminate any field of endeavor. It's very specific to the product, and it restricts other software. So common open source, this is a common open source license model. um, there are some applications that are restrictive and there are some applications that are permissive. Open source applications are more permissive than restrictive, because they are not licensed, they are free for everyone. So if you take a license that is from an open source application, this license may have high or medium or low impact depending on who's distributing the software or who's distributing the packages. So you need to bear in mind whenever you're working in the DevSecOps space to ensure that if you're using any open source dependency, find all the vulnerabilities, have a general knowledge, an idea of how the code is being compiled, how it's being created, and check that the rules of how the code is being compiled aligns with the standard security practices. And for example, there's what we call software composition analysis, which is something that is done usually when you're scanning a code that has been built. Usually, when you build an application locally, it usually has some form of artifact or some form of package. For example, if you're building an npm package, you can decide to uh, build your npm and it comes out with the npm repo, the node modules. Or if you're doing something like a Maven or a Gradle, it can help you come up with a Java file, or it can help you come with a zipped file. And you can even use Python to build an artifact. And you can use Azure Artifact to share and organize your packages. Now, you can plug in a software composition analysis tool to the built artifact that helps you to check if the application that was built is actually in adherence to best security practices. For example, you don't want to compile an app using Maven, and then you discover that the version of Java that you're using or the dependencies that you're using are susceptible to log4j vulnerability. If you do that, you're putting your users in harm, you're putting your own application also in a bad space, because people won't use an application that have exposed their private information to other people or third parties that they do not authorize. It's something that nobody ever takes. So using our Azure artifacts, you can plug in software composition analytic tools that would help you to scan those built artifacts and then make recommendations or findings based on what it has found in those artifacts. Now, you can use Mend, one of those simple plugins that can be used, which is available on the Azure DevOps Marketplace, is Mend. Mend is a tool that helps you to consume your external packages and checks for the open source security, the quality, the license compliance, and it detects the component that was used to build that software and sends you an alert if there is any vulnerability that is found, and can automatically help you enforce security practices on that app if you enable auto enforcer on it. Basically, how it works is you have a code that is on GitHub, and then you push that code to GitHub, or from GitHub you push it to your Azure repos, or from your local machine you push it to either GitHub or your Azure repos. And as soon as it gets into your Azure repos using Mend, it checks for any available updates that you have for the Mend configuration, and then it starts to scan your code. And if it checks, it alerts you, and then when it alerts you, you can have a pull request, or you can review if you want to make those changes or not. So this is basically how to integrate software composition analysis into your pipeline. You have a developer that works closely with the DevOps team, and the DevOps team, as you see here, the DevOps team finds the vulnerabilities, and from the vulnerabilities found, the DevOps team helps you to check your version control. For example, if a developer finds his code to be vulnerable, he can make the modification on his local machine. And if he doesn't find it on his local machine, he can push his code to the version control tool, which in this case will find if there's any vulnerability. And if it does, it still returns and tells you that you're not allowed to build using this code you'd like to resolve. And then you can resolve it and then do another pull request, which then merge into that current branch, and then can allow you to push your current branch build into the build agent. And when it gets into the build agent can also check, and some kind of tools that can be integrated with your build agent includes Mend, Veracode, Sneak, and a whole lot of other tools by different vendors, which you can also check online. And you can integrate those tools with your build agent, which does an incremental source scan. When we say incremental source scan, it means if you have a file that you've built that is 100 MB, it doesn't scan 100 MB again. It scans and reports the first time for 100 MB, but subsequently, it only scans the changes that you have added to your code. That's what it means by incremental source code scan. It doesn't scan the entire thing, which makes it really, really fast. And we encourage everyone to have some form of security scanning embedded into their CI/CD pipeline to ensure that the team that are working on the application do not commit a code that would affect users eventually. So, giving you one example, we have tools like Artifactory, SonarQube, Whitehorse Bolt, and we have Artifactory is where we store the artifact. SonarQube is a tool that is used to scan static code analysis, and then White Source is a build scanning tool, something similar to Sneak. Now, you commit your code to your repository, and then you build an artifact from that repository, and also push that artifact into your Artifactory. Upon getting into Artifactory, your Artifactory holds the exact replica of your artifact. And then your code that you've pushed, you can integrate SonarQube with your code that you've built. And SonarQube can scan your repository for you. And if there's any vulnerability found, it tells you if there's a vulnerability found in your code. It is possible that there is no vulnerability in your code, but there'll be vulnerability in your build. So to help you take care of that situation where there is no vulnerability in your code, but there's a vulnerability in the build, which is what is generated after the code has been pushed, we now integrate another tool called White Source, which is currently called Bolt, that helps you to build a scanning tool. It helps you to scan the build that has been generated. In this case, that can be the artifact that is currently in Artifactory. So upon doing that, the scanner now reports to you and tells you that you have a vulnerability which is on the medium category, and this is the breakdown of the vulnerability. This is the licenses and the risk and the outdated libraries. And sometimes when you run vulnerability scans, and this is very common in anybody that works in the security environment, there's some things we call false positives. False positives are some things that some tools will recommend that you do, but eventually it's not really necessary. I'll give you one common example. What if you run a scan in a cloud environment, and in that cloud environment in Azure, it tells you that you need to implement monitoring in certain regions, which is best practice. But in that region, if you do not have any resource in that region, it is best practice for you to implement it. But if you do not have any resource at that time in that region, there is nothing to monitor. And because you don't want to incur a bill to monitor an environment where you do not have any resource currently ongoing, it's best that you can classify and flag that as a false positive and ensure that users do not build any resource or create any resource in that environment, because it would expose you, because you do not have that place covered for monitoring and compliance. So static code analyzers, example is something like Sonar Cloud. Sonar Cloud looks something similar to this, and it reports the findings for you. It tells you various findings that's been built into the backend algorithm of SonarCube. It tells you where you have your codes that are affected, and it's a very, very reputable company. They have joint investment with Microsoft. They have a wide range of programming tools that they support, and they also have a cloud hosted version which is called Sonar Cloud that can integrate via APIs and directly help you to scan your artifact or your static codes. So another example is CodeQL and GitHub. So it treats a code like a queryable data or a standard or custom analysis query. And basically, what CodeQL does is you create a database in CodeQL, you run the CodeQL query against your database, and it finds any vulnerability inside that database for you. So this is another way that we use static code scanners in the space. We also have OWASP and dynamic scanners. Basically, dynamic scanners help you to scan not just your static code, but codes that are being built in the build processes. And in the build process, I'm going to give you an example. In this example here, you have a build that you've triggered, and you have a static scan, and you also have your package that is being built in that pipeline, and you have your deployment, and you have your passive penetration test. Using OWASP and ZAP penetration test tools, you can run your penetration test directly against your environment without breaking anything. Your test can either be active or passive, and active or passive means it can either be ongoing exactly at the time of the build, or it can be working in the background while your build is being compiled, and it can go back to check, or it can do a quick baseline scan to identify vulnerabilities that are in that environment. And finally, it can conduct nightly more intensive scan, maybe for time when you guys are not really using the application. It can run background checks constantly and give you the reports in the morning. So this is one of the best ways that we've used the OWASP ZAP's result and bug. So in essence, the way it works is that the dashboard looks something similar to this, where you have different vulnerabilities found. For example, this is an OWASP vulnerability scan. These are all the security tests that have failed. For example, there's incomplete or no cache control for HTTP header set, and cookie accepts HTTP flags, which is not best practice. So these are some of using the OWASP ZAP results, OWASP ZAP scan. This is what the dashboard can also look like when you run a scan against the environment. So the quick question is, I know a lot of people ask, what security policy tool should I use? How can I, now that I know that I need to secure my environment, what tools do I need to put in place to ensure that my environments are constantly secured? Well, the tool that you need to put in place is up to you, because as I defined earlier, you need to first define your environment, identify your architecture diagram, find vulnerabilities in that environment, and then work on those vulnerabilities and fix. Now, if you are working in Azure DevOps environment, which can be integrated with a wide range of existing tools, I mean, there are hundreds of tools that check security policies that can be integrated with your Azure environment. You need to come up with which security tools you intend to use. And you also need to ask yourself, what do I like about these tools? What do I not like about these tools? For example, if you were to integrate security into your current cloud environment, I would recommend you scope out at least three security tools that can be integrated with the Azure environment, and then try out, request for a trial license for those three tools, integrate those three tools with your cloud environment, test it, see how the application works. And if you are impressed by the one that you're most impressed with, is the security tool that you need to go to, because we all work differently and we can have our preference. Now we go into security and compliance. If you want to go into security and compliance and governance in the cloud space, we use traditional operational tools for protecting items and assets in the cloud environment. But security in the cloud has gone beyond just using basic authentication tools like username and password. You need to start integrating apart from just multi-factor authentication, you can even have a dynamic USB key that has high algorithm to help you secure your most critical applications. You need to have your CI/CD pipelines to be in an immutable structure, such that everything that goes into your production environment must pass through that CI/CD pipeline. You need to ensure that you use the RBAC policy management for ensuring that your password or those who have access or whatever has access to your pipeline is secured. And you need to also ensure that you continuously run dynamic scanning, such that apart from when an application is being created, you can also run a penetration test in that environment to constantly scan for the application. So there are multiple applications or multiple policies that can help you to secure your cloud environment. Example of them is something like Microsoft Defender for Cloud. It provides you with a very robust security recommendation. There's a Microsoft Defender for operating system, which I know most people know about, but there's also a Microsoft Defender for Cloud that provides you with Microsoft native secured cloud tool for monitoring your environment. It can help you monitor your service. It can analyze and identify potential attack. If a user that does not have access to your environment or to certain resources tries to access those resources, your Microsoft Defender can send you a notification to say that this is what we are noticing in your environment. And it supports Windows and Linux operating systems. So this is not just tied to Windows. If you have a virtual machine or you have a container, and in whichever of them the operating base operating system is currently in Linux, Microsoft Defender also supports it. And it also monitors security settings and uses Azure machine learning to continuously keep in touch and being intelligent and being above of the curve of potential attacks that may happen to you. And it's also applicable in multiple pricings. This is a use case of how Microsoft Defender for Cloud works. For example, you can use Security Center for Microsoft Defender to help you with Security Center incident reports. You can also use that to help you detect, assess, diagnose, close, and stabilize your cloud environment. There's a scenario too where you can use it for enhancing your security. For example, it can scan and make some security policies and then give you some recommendations, and then you just implement that recommendation in your environment. You also have Azure policy, and Azure policy is a must-have. It's a must-have for any Azure DevOps environment that I'll recommend to anybody. It's a service that Microsoft Azure creates, have built, and it allows you to create and assign and manage policies. It is best to use policies to manage both users and resources, and you can create roles and groups, but make sure that there's a policy at the bedrock of all these things. Having policy mitigates you from having to create multiple complex user roles or giving users unnecessary permissions. So Azure policy can provide reinforcement using policies and initiatives that are strongly recommended by Microsoft. And it can run evaluation on your resources and scan for things that are compliant or not compliant and display it to you on a beautiful dashboard that allows you to constantly be at the top of your game in your DevOps environment and making sure that you are now fully integrated with the DevSecOps practices. It also integrates with Azure DevOps by applying continuous integration and continuous deployment to your pipeline and policies. And this is what it basically looks like. It's something written in, as you can see, we have it written in JSON, and you can assign policies either using your Azure portal or your Azure CLI, or if you're like me that likes PowerShell, you can also use PowerShell to help to build a policy. And it's very simple. For example, you're looking at a screen here, you can give the policy a name, give it a description, so that if there's anybody on your team that needs to have visibility into it, they know what that policy is about. And you can define the policy rule that states that what is allowed and what is not allowed. So using this can help you to resolve a whole lot of things and keep you compliant in the DevSecOps space. A typical example of using this is you have a policy. The policy helps you to check compliance for something, and then it assigns a permission or an action to that policy to say if you are compliant, allow or deny. It's basically something like that. So you can also use the resource locks on the policy. So resource locks basically prevents people from deleting resources in the cloud space. For example, you don't want to have a production environment and someone with admin rights just deletes it. You might have people with admin rights, but they might not be real business decision owners in a company. And if you need to delete an application that is in production, it needs to go through a proper change management system. So you do not want anyone just going into your environment and deleting resources. You can imagine if someone is trying to hack you, and then the person gets access into your environment, and then all of a sudden it just deletes a typical application. That would be very, very disastrous to the company. So you won't want this to happen. That's why we always recommend that you use the resource lock in your Azure environment. And then you can also use something called Azure Blueprint. And Azure Blueprint is a feature on Microsoft Azure that allows for the definition of repeatable set of Azure resources and ensures that everybody stays in line with that. You can create a blueprint, assign the blueprint, and then track the blueprint assignments. For example, you can create a blueprint and attach several policies to it, and then you can track how that blueprint has been assigned to anybody. So this is what the Microsoft Defender looks like from the dashboard, where you can, for example, this is Microsoft Defender. It has scanned my environment and it has found recommendation, subscription, resources that it has accessed, any active recommendation, and these are insights. So these are some of the insights that you're supposed to get when you have your Azure Defender in place. Some applications might have maybe FTP or FTP just opened and not using FTPS, or a web app might not be using SSL. We might have some policies that are not that best practice. You can find that easily from this dashboard. So this is that beautiful dashboard that I was explaining to you that you can get from here. So we're supposed to have a lab to make some changes or to do some of this demo, but unfortunately, we won't have enough time to make that lab. So I guess I have to stop here and give it to Back Promise, who can then give us, any questions that people might have to ask. Thanks.
Hello, Tayo.
Hi, Promise.
Yes, how are you doing? That was a
Great.
very interesting session, by the way.
Thank you very much. Thank you very much.
So while you were actually trying to explain just the last topic you talked about,
Yeah.
one of our attendants asked that question, and he was like, "If you can demonstrate, you know, how to implement a code scan on pipeline."
Okay. So unfortunately, we do not have a demo pipeline, but if we can have a session, maybe another session, probably maybe next week or anytime, I can build that pipeline and then have you integrate. We can walk through that process of how we integrate the what's it called, the scan into that pipeline, using the Azure marketplace tools that I was speaking about in the slides. But for now, we don't have it on this slide, so we cannot do the demo on that.
Okay, thank you very much for that, Tayo. Okay, so I don't have any more questions. I've asked the audience to drop their questions, but I personally I have one question to ask. So we are talking about how to implement security on our pipelines, right?
Yeah.
I know there are various ways, to implement security when dealing with pipelines, but in terms of cost, what do we need to consider in
Okay.
terms of cost?
So in terms of cost, what you need to consider to secure your pipeline is based on your current budget. Now, if you have a big budget, it's highly recommended that you implement your security scan in each stage of your pipeline. But if you do not have a big budget, we have two ways that we can go about this. The first way is you could set up a VM in Microsoft Azure and get any of these recommended sources of security scanning tools installed and deployed into that virtual machine in Microsoft Azure. And then you can integrate your repos or your build tools with that scanning tool. That gives you more or less like a cloud-based, on-premise cloud-based kind of infrastructure that helps you to organize your scan. Now, if you do not want to do that, another way you can do this is to integrate with services like e.g. Sneak. Now, Sneak can give you an API scan, which you can run in your build steps, and you can also run this in your terminal. So, if you have a cost constraint, it's highly recommended that you start fixing or scanning or implementing security classes when you are writing your code and not when it gets into the development place because it gets more expensive. So you can also use Sneak Scan on your terminal to scan and analyze your code, and that will help you to save more costs. So you can begin that on your IDE before you eventually move into the cloud environment.
Thank you very much for that. Right.
Yeah.
This just makes me think of a scenario that happened recently. I think that was with the Uber hack, right?
Yeah.
Where
Mhm.
some developer or some hacker somewhere,
Yeah.
decided to invade their private space and then posted some funny things on, I think, their Slack channel,
Yeah.
right?
True.
So, I mean, one of the things I know is that when it comes to pipelines like this, I would say that security cannot be overemphasized. Like, this is something I feel you always have to put into consideration when dealing with your pipelines. And just like you
True.
said, I mean, it's always good that, well, even if you have to factor in costs, deal with what you can at the
Yeah.
so you don't experience issues like Uber did. Trust me,
Yeah.
expenses on security cannot be overemphasized.
Emphasize. True.
Thank you
I mean,
very much for that, Tayo. Yeah, go on,
thank
go
you.
on.
I mean, no, just in addition to that, there's something that we also need to do, which is constant education. Educating people about security is something that we need to do as much as possible. The Uber hack happened based on social engineering, and the funny thing is there is nobody that is immune to social engineering. You can only be aware that it cannot happen to you. It can happen to anybody. Social engineering can happen. They can attempt it on you. They can attempt it to me. It can be attempted to anyone. But the point is being aware, having the information and the knowledge of what social engineering is about, how security can be compromised from you being a staff is very, very critical. Having such knowledge would empower you to know how best to react when a social engineering is happening. Unfortunately, my condolences to Uber. It happened before they could even know that this had happened. So, I mean, I really don't envy the security guys, and I hope they come out of it really soon.
All right, thank you very much for that, Tayo.
You're welcome.
We have two questions here, not
Okay.
necessarily related to implementing security to validate your code and all of that. But
Yeah.
nevertheless, I feel we can give the audience, a feedback on some of their questions. One of the questions I asked is, why is getting a junior cloud role job very difficult? I don't know if you
Okay.
could give us some light on
Yeah. So the truth is when you talk about junior cloud role, a lot of people do not understand where we're coming from before we even started the cloud journey. And if you understand where we're coming from before we started the cloud journey, you would appreciate what it means to even have the concept cloud more. Um, where we're coming from, we used to be on premise. We used to have our applications sitting in our offices. And then we started migrating from having physical machines to virtualization. Virtualization helped us to move physical boxes into virtual boxes. Now, From moving into virtual boxes, we moved a whole lot of components with it as well. You move your storage, you moved your network, you moved a whole lot of things and permissions, operating system into the virtual environment. And after moving into a virtual environment, we moved into data centers. And after moving into data centers, we have now moved into cloud. Now, on an average, if you look at the journey of what I've just described, it is not something you just wake up and stumble into. It's a fundamental that you need to understand. And because cloud is now like at the admin, and now when we're even talking cloud, we're not just stopping here. We're looking at containers, we're looking at functions. Now, if you look at it from these angles, it's even gone beyond just cloud. We're looking at containers and we're looking at functions. So the virtualization has even gone a step beyond just putting virtual machines in cloud or in a data center. And because of this unique growth and progress phase, you cannot be a DevOps engineer as a junior DevOps engineer. You can only be a DevOps engineer or you're not a DevOps engineer. However, you can be an aspiring DevOps engineer, which means you have to spend your time to learn this journey of where we are coming from. How does it work? What purpose would it serve? How do people connect to it? How do people used to connect to applications before? How do you view your browser? How do you connect to the database when it was on premise? How do you connect to it when it's in a virtual machine? How do you connect to it now that it's in cloud? How do you manage the permissions? Because these applications do not just move from where they are directly into cloud, they moved in phases, and each component, permissions, operating systems, firewall, all those services also moved. So for you to be a DevOps engineer, you need to actually burn the candles. Unfortunately, it's not hard. Unfortunately, it's also hard. So um it requires dedication, but I believe that if you can dedicate time and give yourself at least a 2 hours every day for learning, within a space of maybe 120 days, you should have a good grasp of what the DevOps is about. So I hope that helps explain why it's difficult to get that role, because organizations are not looking for someone that will just come in and mess the application up. They are looking for someone that has a good grasp of how these things work.
All right, thank you very much for that, Tayo. Funny enough, while you were just speaking on this, follow-up question came in,
Yeah.
very similar, right? But this time
Okay.
around, he's asking, I think what I can differentiate from the previous question was any idea how one can get such roles locally and abroad, like ideas where
Okay. Yeah, true.
this young able to get those roles.
Of course. So the first thing is knowledge. You need to empower yourself with the knowledge of how the cloud itself works and how DevOps works. You see, don't be in a rush. DevOps, like I always tell people, DevOps is not a sprint, it's a marathon. And it's a marathon because you need tenacity and endurance to push through. So starting from there, you need to be really, really interested in knowing what you're doing. And secondly, when you know what you're doing and you have the knowledge, try to have your own repos, your personal repo stored in maybe GitHub or Azure repos. And then when you have your repo stored in cloud, you have sample projects that you commit into your repo that you interact with. You also need a cloud environment for yourself, a cloud environment where you have your applications hosted, where you have your repository hosted, where you have your artifact storage or your CI/CD tool hosted. And then you're able to interact with it like you are in a real office. Now, after getting this good grasp of that knowledge, I always recommend that you volunteer. Volunteer is the easiest way to get a DevOps job. When you volunteer to someone and they see your competence and you work, I can tell you there's hardly anyone who volunteers to work as a DevOps engineer to anybody. If you really perform and you finish your tenure, there is nobody that will not want to keep you. Even Promise here, if you volunteer to him as your DevOps intern and you are able to develop, it's just that I don't know if Promise has any opportunity in his office, but if you volunteer, you get the experience on the job, and then there is no organization that will really want to let you go for volunteering because you worked for free. So the easiest way to get into a DevOps job when you do not have any DevOps knowledge is to volunteer. Volunteer because you want to get real professional experience. Some companies might not have the budget to employ you or take you in as an intern and pay you, but they might be able to squeeze you in as an intern. And if you prove your worth, trust me, you would either get a new and better offer or the company will retain you. So that's the easiest way for an entry level aspiring cloud engineer.
Wow, I mean, Tayo, you just broke what was the nail on the head, right? I mean, this is something I'd always encourage everyone to do. Like, I mean, there's nothing like volunteering. You see, some of this work we even do, just like I am tired. We're actually volunteering. Nobody is actually, getting paid
True,
for this. We're actually volunteering our time, our
true.
knowledge, our skills, just to ensure we're able to impact this knowledge to people, right? So,
Yeah.
I mean, that's a great one, Tayo. Um, we have some few more minutes, right? But then questions are coming in. Apparently,
Yeah,
it looks
sure.
like you are actually engaging the crowd. So there's a question here that says, apart from code scan, do we have infrastructure scan tools? And if possible, if you know these tools, can you name them? You have an
Okay.
idea of infrastructure scan tools? Yeah.
Yeah. So there are tools that can actually help you scan your infrastructure. And those tools are classified into two categories. They can either scan your infrastructure if your infrastructure is scripted as a code, like the session we had last week. The code that we used to build up the infrastructure was written in a YAML Azure bicep template. And then there are tools that can actually help you scan an existing infrastructure that was built from the console graphic user interface. Now, example of those tools are tools like Qualys, like Rapid7, like Sneak and Veracode. They can be integrated in your cloud environment and then scan for compliance. They can scan, for example, you might have a blob storage in Azure, and your Azure blob storage by default is recommended that your storage should not be exposed publicly to the internet except there's a unique need. And if there's a unique need, you need to have like a web application firewall that would help you to block that, and a load balancer that will also sit there, and maybe a content distribution network of some sort that sits at the edge to ensure that users are directed securely to that S3 bucket or to that Azure blob storage. Now, if you go through that flow, if you have a tool that can help you scan and you have a blob storage that is publicly exposed, it can tell you that this storage is exposed publicly. It means if anyone launches it on their browser, it takes them straight into whatever information that you have there. So to prevent that from happening, what we usually do is to employ the use of these infrastructure scanning tools. So there are lots of them, and these tools that I've just mentioned can do both infrastructure code scanning and also infrastructure scanning from the web console interface. I hope that answers the question.
I mean, like I said, you have a way of just hitting these questions right and direct. Funny enough, like I said, looks like these people are actually getting engaged, and I see more questions popping up. Now,
All right, sure.
funny enough, some of the questions I'm seeing are not really related to the topic we are talking about. But I mean, for the meantime, I feel like we can indulge them, just see if we can provide some answers to them. So the next question we have here is, I mean, what is the difference between site reliability engineering and DevOps? Is
Okay.
there any
So
specific difference?
yeah, there is a difference between site reliability engineering and DevOps. So let me explain to you from a layman's concept. If you're coming from a background of software development, so let's say we have two people that want to be in the DevOps space. One person comes from an infrastructure background, maybe he used to manage servers and desktops, and then or networks, and then you have another person who used to be a software developer, and both of them want to go into the DevOps space. Now, when the both of them get into the DevOps space to start working individually or learning to become a DevOps engineer, DevOps is a practice that allows you to help development team build code faster and release their code, in a much better environment. Now, SRE, which is site reliability engineering, is involved in also building that code faster. But there's a difference. The area of concentration of a DevOps guy is centered around building your code and delivering them securely into the production environment, and also doing monitoring, but not too much. A site reliability person is concerned about monitoring and availability much more than just building through your pipeline. The reason is because an SRE engineer is solely responsible for making sure that your application never fails. I mean, once it is launched and is in production, it should never be hacked. If it's suffering from high memory utilization, there should be a mechanism that can upscale easily to ensure that the application is not failing. So all that's around the focus of an SRE engineer, and an SRE person also has much more to do in terms of scripting and programming than infrastructure compared to a DevOps person. A DevOps is mainly focused around pipelines, helping your codes to be built properly and then being pushed. But an SRE person is more involved in the software side. So they basically do the same thing. I mean, I have been in several teams where I have been in the SRE team, I've been in the DevSecOps team, I've been in the DevOps team, and I can tell you that both all three classes of people do practically the same thing, but the area of concentration slightly varies, like I explained.
Tayo, I mean, you've given us an in-depth understanding about that, and I'm really happy you did this. We are actually out of time, right? But I would just like you to just give us just a quick summary in 1 minute.
Okay.
What you would say implementing security and validating codes on your code basis for compliance is all about. Just in just 1 minute, just give me a quick summary.
Yeah. Sure. So, validating security and implementing security and validating your code base basically is a concept of making sure that when you write your code, you are adhering to the safest and best practice security standard to ensure that when your code is released, it is not only of high quality, but is also secured in terms of the application performance and in terms of the data that the application takes. And then the compliance is ensuring that you're constantly monitoring your application and your infrastructure, constantly monitoring the two of them to ensure that your both application and infrastructure are in line with best practices. And there are several security practices. The example is the CIS standard. So ensuring that your application and your infrastructure all sit securely according to best practices as defined on the CIS standards. That is basically what implementing security and ensuring code compliance when you eventually build your code is about.
All right. Thank you very much, Tayo, for that brief on our topic. I would say fortunately, and let me not say unfortunately, but I mean, time is up, right? So, I mean, I can see everyone pausing. I'm seeing a lot of questions. People are asking so much about DevOps. And I just want all of them to know that, look, what we are here to do as Azure Nigeria community is to ensure we are able to pass down this knowledge. Now, we have several programs. Aside the DevOps track, we also have upcoming programs for the Azure Administrator track. So what I would just like you to do is go to our link, join our pages, this way you get informed of the programs and that we have planned up for this quarter session, right? So, I mean, if you haven't, what's the word, registered in our meetup link, right? I would advise you to register on the meetup link so that whenever we send our mails out for upcoming programs, you'll be the first person to be aware of those. And now, next week, we also have a session coming up, and we'll be able to provide more answers to your questions, even as we delve onto other topics in the AZ-400 series. But for now, I would just like to say we will see you next week, and we are not leaving you behind anyway. We are carrying you along, but then, I mean, time is up, so see you guys next week. So, Tayo, it was a great session. I'm happy we were able to do this, and I mean, we keep pushing out the knowledge out there. I'm none other than Promise Uche Nwachukwu. I'm a senior consultant, CloudOps and DevOps, and I'm going to be your host for this period of sessions. Hopefully, I should be acknowledged with you, and I'm going to be coming up with various interesting speakers from the DevOps industry. Thank you all, guys. See you all next time.
Thank you.